In this lesson, we're going to be looking at factoring with three terms where the leading coefficient is a 1. Yesterday, we factored with 4 terms, so let's do a little review. When you have 4 terms, the first thing you do is you look for a greatest common factor for all 4 terms. There doesn't happen to be one in this example, so now we're going to break it into 2 groups, and we're going to pull out the greatest common factor from both groups. First, we have x cubed plus 2x squared, and the greatest common factor is x squared. When we divide both of those terms by x squared, you're left with x plus 2. In the second grouping, we have 5x plus 10. The greatest common factor is a 5. If we divide both terms by 5, we are left with x plus 2. We will see here that the magic happened. We got identical binomials, so that's one of the binomials in our answer. And our other binomial comes from what's outside the parentheses, x squared plus 5. So here is our answer, x squared plus 5 times x plus 2. In another example, we look for the greatest common factor for all 4 terms. There is not one, so we break it into our 2 groups. That's why it's called grouping. We're going to pull out the greatest common factor for the first grouping. That would be 2n squared. Now if we divide both of those terms by 2n squared, what is left? We have n minus 4. In the second grouping, negative 3n plus 12. The greatest common factor would be a 3. Now I want there to be an n minus 4 in here, so what I'm going to divide by, do I need to divide by a negative 3 or a positive 3? I want this to be positive, so I need to divide by a negative 3. So I'm going to make that negative. And when you divide by negative 3 here, that makes that negative 2, which is good. Now we see that we have the n minus 4 and the n minus 4. We want those to be identical. And then to write our second one, we take what's outside. So you have 2n squared minus 3. So our final answer is that, 2n squared minus 3, n minus 4. Today we're going to look at, here's one more example. I'm just going to skip that slide for the video so we can move on to today's lesson. Today we're going to look at factoring with 3 terms where the leading coefficient, that means the number in front of the x squared, is going to be 1. We're going to use a method called reverse FOIL. First of all, you need to know that the coefficient in front of the x squared is called the a term. The coefficient in front of the x term is called the b term, and the ending one is c. So when I refer to a, b, and c, you'll know what I'm referring to. In reverse FOIL factoring, what we want to do is we want to find 2 factors that multiply to get the c term. But those same 2 factors have to add together to get the b term. So the first thing you do is you look at the last term, the c term, and you think about factor pairs that you can multiply together to get a positive 8. So I listed them out here for you. We have 1 times 8 makes 8, and 2 times 4. These are the only 2 factor pairs where they get 8. Now what you want them to do is you want them to add together. We're going to take those same 2 numbers, but we want them to add together to get the b term, which is 6. So 2 plus 4 is 6 right here. So here's what we're looking for. We're looking for the 2 numbers that multiply to get the c term, but when you add them, they get the b term. So our pair is 2 times 4. So what we're going to do is we're going to make our 2 binomials, and we're going to take one of the numbers, plug it in here, one of the numbers, plug it in here. So our 2 binomials would be x plus 2 and x plus 4. Now, if you did the FOIL, you would check it and see that you're going to go right back to this equation. So x times x is x squared, 2x, and we have 4x. See the adding right there? When you add them together, it gets to be 6x. That's why we were adding right here to get this term. And then 2 times 4 is 8. That's why we multiply to get the c term. And indeed, we go back to that equation. This just takes practice, so let's practice again. So here we look at the c term. We want 2 numbers that multiply to get a 16, but they add to get a negative 10. So the first thing you would do is think of the factor pairs that you can think of that multiply together to get a positive 16. I wrote them down here for you. We have 1 times 16. A negative 1 and a negative 16 also results in a positive 16. 2 times 8, a negative 2 and a negative 8, and 4 times 4. Now remember, we want them to add together to get the b term, which is a negative 10. So here's what we have right here. These are the two numbers we're looking for that multiply to get a positive 16, the c term, but add together to get the negative 10. So we're going to take those numbers and we're going to plug them into our binomials. So our answer would be x minus 2 and x minus 8. If we use our FOIL to check, x times x is x squared. We have negative 2x and negative 8x. That's where they add together to get that negative 10x. And then you multiply and get positive 16. So it checks. X squared plus 13x plus 42. Let's think of the factor pairs that make a 42. So I listed them out here for you. We have 1 times 42, 2 times 21, 3 times 14, and 6 times 7. But we want the pair that adds together to get the 13. This right here is, I'm not supposed to say 42. That's the multiplication of it. 6 plus 7 is 13. So here's the pair that we want. So we're going to plug those in. It was a positive 6 and a positive 7. So that would be x plus 6 and x plus 7. If we do our FOIL, we have x times x is x squared. We have 6x plus 7x. That's where we add them together to get the 13x. And 6 times 7 is 42. So we go right back to the original equation. Here we have x squared minus plus x minus 20. So let's see what the factor pairs would be that results in a negative 20. This time we want a negative 20, so we know one of the numbers is going to have to be negative. So if we look at the pairs here, all of these result in a negative 20, all of these, but we want it to add together to get a positive 1. Well, negative 4 times 5 is negative 20, but when you add those together, you get a positive 1. So those are the numbers that you're going to plug in here. So that would be x minus 4 and x plus 5, and it would check. More practice, x squared plus 7x minus 18. Let's think of the factor pairs for a negative 18. We have 1 and 18, where each one of them could be negative. We have 2 and 9, where each one of them could be negative. And we have 3 and 6, where each one of them could be negative. But we want it to result in a positive 7 when you add. So when I look at this list, I see right here that negative 2 and 9 would result in a positive 7. So that's how I kind of go through the thought process when I'm doing it. So we write down x minus 2, x plus 9. This time we want it to result in a negative 24 when we multiply. It's a negative number, so one of the numbers is going to have to be negative. It could be the 1 or it could be the 24. We could do the same thing with 2 and 12. We could do the same thing with 3 and 8. We could do the same thing with 4 and 6. But as you're going through these, remember you want it to add together to get a negative 5. So as soon as you find one that gets a negative 5, which is right here when you add the 3 and the negative 8, then you know that you have your winner, what you're looking for to make your two binomials. X squared minus 6x plus 8. Okay, so add together or multiply together to get 8, but add to get negative 6. So we have 1, 8. Notice this is a negative number. So when we add together to get a negative number, we may have to have a negative over here. So we could have 1 times 8. We could have a negative 1 times a negative 8. We could have a 2 times 4 or a negative 2 times a negative 4. And right as soon as I write that one, I'm thinking about what I have to add together. And I see that a negative 2 and a negative 4 is a negative 6. So my final answer is x minus 2 and x minus 4. I hope this helps you with factoring with 3 terms where the leading coefficient is a 1.